Thank you everybody for coming. Good morning, good evening, good afternoon. I don't know what kind of time zones are we streaming to today, so just a simple hello should do. This is going to be a very basic presentation about HugePages. You will notice that I tend to speak quite too much and quite too fast, and my accent may make it even a bit more difficult. So just post your questions in the Q&A panel, and we'll have some time at the end to answer them and see what we have to repeat or whatever. Yes. Okay. On the presentation itself, as I said, this is a very basic one. It's meant to be a refresher for most of us DBAs, because these HugePages thing has existed since like forever, in 2020 that we are. But and the idea is that for the senior people to get a grip on what's going on with HugePages and to refresh their knowledge, so they can maybe review their systems and see to set them. And for the juniors that may be joining us today, the idea is that they get an idea of a glimpse of what kind of stuff they can find in related to memory issues and the sorts. A little bit about me. Name is Jose Rodriguez. I'm a project engineer at Pythian, been there for 3 years now. I'm an ACE associate. I've been working on database stuff more than 10 years now. Anything you may think of, Solaris, Linux, Windows, high availability, replication, all that kind of stuff. Obviously, cloud is everywhere nowadays, so everybody's working on cloud one way or another. I'm from Spain, if you haven't noticed yet by my accent. It's early in the morning here, not that early. It's a bit chilly to be Spain, I know. So again, if my accent may pose a problem to anyone, just pose a question in the Q&A panel, and we'll see to answer it later. There you go. So about Pythian, we're roughly 400 now. We provide services, data-related services on follow the sun model. We've been here for more than 20 some years now. We probably will be here for a few more. A bit of information figures about the company, which I find amusing. We have like 10,000 systems managed by us, 400 people throughout 35 different countries. And the funniest one for me is that we overall sum up a total of 2 millennia of experience in the last, as I said, 20 years or so. So what are you taking away? What is this about? I'm going to try and explain why HugePages are important for DBA, what HugePages are, how do we set up them for our databases to use them, and I will be showing a couple real life examples where HugePages, or actually the lack of, where the source of an issue or when related to an issue, and we had to fight. Okay, let's go on. Why HugePages are important? It's 2020, and still HugePages do not seem to be broadly used or understood even. We've all seen huge systems now with up to 1 terabyte, even more, of RAM, and handling this amount of RAM is not trivial. And unfortunately, when a database is behaving weird, it's not responding in time or whatever, and the problem is because of HugePages, it's not easy to troubleshoot and to find as a root cause. Now, what's behind the scenes? What is a huge page? As you may know, each process has several physical memory segments allocated. Those are typically not contiguous due to NUMA or ASRL, things that are meant to improve the speed of the physical available RAM, but mess about a bit with the accesses. So what the system builds is a virtual memory map, a table that tells the process how to address the physical memory segment. Right? This is typically called the translation look-aside buffer table, which is limited in size. So the moment we get a number of huge pages, that table does not reside there anymore, and we have to go back, kind of swapping, but at the processor level. So in order to track these pages, the kernel will use page tables. These are memory structures that keep the pointers from the virtual to the real memory segments. And here's a very important piece of information. Each of these entries uses typically 4 kilobytes in size. Not the entries in the table, but the segment allocated. So the user process will have its own copy of a page table to map its own virtual memory segments to the physical ones. So what's the problem with page tables? Let's say we have a quite big SGA of 100 gigabytes, which will basically mean we have a memory table of 26 million entries of 4 kilobytes each. So each of these entries in the memory in the processor page table is around 8 bytes, typically for Linux 64-bit systems, which includes the offset, the physical address, and some flags. All right. This table is stored in memory as well for the process to access it. And in our particular example, this table will be roughly 200 megabytes. Now, for a shared memory segment like the SGA we're working with in our database, each process, and by each process in this case, it means each of the sessions connected to the database will have its own copy of the page table. So let's say we have 100 sessions, 200 megabytes per session. That is roughly 20 gigabytes of RAM just to store these page tables in memory. You can imagine what that kind of memory usage does to a system. So HugePages to the rescue. What is this? Okay, the problem we have is that we have very little memory pages, 4 kilobytes. And for SGAs, we're using big amounts of memory, which means that we have a lot of these. So the idea is that instead of 4 kilobyte pages, we use bigger ones, huge pages. In this case, 2 megabytes is a typical value in our most common Linux system. So what we're talking about here is that the memory page is grown to 512 times. So the immediate effect is that the number of pages we have to handle and store in our memory in our page table is reduced by that amount of times. So in our example before, it means that from 200 megabytes, we go all the way down to roughly 400 kilobytes. Now, with our 100 session, that's about 40 megs, which is really, really, really good, a good improvement. So important things about HugePages, because it's not all magic. It's not just, okay, let's implement HugePages and we are all set, our database will be fast and that's it. No, of course not. That's not the case. The tricks of HugePages is we should only allocate enough HugePages for our needs, because if, there are processes in typically in our operating system that may not be able to use them for whatever reason, or 2 megabytes may be way too much for a process that only needs a few kilobytes for whatever the reason. So just be careful with that. And particularly for SGAs, if we have a 16 gigabytes machine and we allocate 16 gigs of HugePages, there won't be any room left for the OS itself, which you may know it. It is a particular problem. HugePages are not trapped out, which means from a database perspective, it may be a good thing that our memory doesn't go to disk, but that may introduce some additional issues with the kernel trying to swap them out and not being able to. Memory pressure is an issue. Right? In Oracle specifically, if we set up automatic memory management, which I don't think anybody nowadays is doing anymore, and if you're doing it, you better review it, because that's not a best practice anymore. It's not been a best practice for a few years now. So AMM is not compatible with HugePages, so you cannot use HugePages in AMM. You have to choose it. Linux introduced this transfer HugePages thing, which basically means we know you don't know about HugePages, but we're going to enable it in the background for you. And that gives us issues with Oracle databases. Luckily, Oracle Linux has this feature disabled by default, but if you still have a relatively old system running with this, or you're going to build a new one, make sure that your kernel is disabling transfer HugePages. All this presentation is based on Linux and my research on Linux and my work on Linux, but other operating systems like Solaris, for instance, may allow for pages up to one gig, which may be the case that they are interesting or resourceful. It's being reported that if the SGA is huge, and I really mean 3, 4, 14 terabytes in size, that may lead to a slow instance startup. Why? Because during the startup, the database kernel will try and allocate each and every page, which may take a while. So there is this pre-page SGA initialization parameter which prevents this from happening, which means that later on the database will try and allocate these pages. So we have a cold start. So again, it is a matter of do you want the performance to be good from the very do you want the database to start up quickly, and then it doesn't matter if a given session takes a slightly longer to start, or do you want the other way around? The database barely ever is barely ever bounds. So I rather it to take a bit longer, and then my sessions will have the memory available right away. So, and finally, related to AMM as well, AMM is starting at 12.2, yeah, quite old version, I know. AMM is directly forbidden by the Oracle database itself if the RAM in the system is bigger than 4 gigabytes, which leads to the tip that HugePages should be used as a best practice if your system has more than 4 gigabytes, which is basically use HugePages always. Okay. An interesting question that I had to answer was, does ASM use HugePages? Well, the question, and this leads to another question. Do we really need or want HugePages for ASM? ASM being this small, not really complete instance that Oracle uses to manage these. Now, initially, ASM uses AMM by default. So this this leads to HugePages not being compatible. But the documentation and some best practices documents say that ASM may not be using AMM for whatever reason, especially Exadata. And if basically the message here is, okay, ASM instance is typically very small, but in systems with a huge amount of disks, of ASM disks, the ASM memory, the ASM SGA and the table that it uses to map disks, etc., and blocks, etc., may grow very big. So for those cases, changing the ASM instance to be not AMM but ISMM and enabling HugePages is typically a good idea. All right. Okay, this is specifically for Linux. Dev SHM. Dev SHM is a temporary file system that Linux kernel mounts on boot, typically to the size of 50% of the total available RAM. And AMM, Oracle AMM, when we set up an instance in AMM, an automatic memory management mode, it will use that SHM to store the shared memory pages, right? And if we don't have AMM, we don't need that kind of RAM, especially in systems with, as I said, huge amounts of RAM, about 16 gigs, 32 gigs, whatever they are. So we may see this as a waste of RAM. Oh, I have this huge temporary memory file system which I don't use at all, so I'm going to reduce it. Actually, there's no need, because the memory is there, is listed, but it's not actually being used. So initially, we shouldn't need to do anything about it. And which means that HugePages and AMM are compatible as far as AMM is not in use and it starts eating up our dev SHM file system. And this AMM thing is interesting in dev SHM because in case you didn't know, if you remount the unmount and remount the dev SHM file system, anything that uses AMM will crash. And that means if you have an ASM instance in your node in AMM mode, you will lose all the instances on running on that depend on that particular ASM node. Happened to me. It's not fun. All right. The PGA, the session private memory part. Does it use HugePages? No, it doesn't, as far as I know. That may have changed in the last 6 months or a year. I haven't checked, to be honest. There is no, I haven't been able to find any evidence that clearly says, no, HugePages won't be used for PGA. I ran a few tests back in the day, and initially it seems that HugePages are not being allocated for PGA. Which kind of makes sense because session may be using only a few bytes or kilobytes or megabytes even of memory, and using HugePages for that may be counterintuitive, right? Obviously, this is Oracle and everything is changing constantly, and this may change in the future, especially in data warehousing or data ODSS systems. So cloud, of course. HugePages in AWS, RDS, in the RDS service, are available and supported since 2017, but they were not enabled when I ran this test. They were not enabled by default, which probably is still the same. And there are limitations to the type of instance you can enable HugePages on. Obviously, because if you get a small instance with not much memory, and depending on if it's share or whatever, HugePages may not be a thing. I've been unable to find any official documentation on Azure, but I ran a few tests and I found that you can set up HugePages in a Linux virtual machine running on Azure. So the full support will probably come if it is not there already. Google Cloud supports HugePages, and the Oracle Cloud Service uses it by default for Exadata and such. I don't know the internals of ATP, Autonomous Transaction Processing, Autonomous Data Warehouse. They're probably using HugePages, but in a different setup. There's nothing we can do about it. So. Well, the old cloud infrastructure allowed it, but not by default. So and the classic platform, which I think has been retired already, has HugePages enabled by default. So we should be fine. And the cloud using HugePages. All right. Let's set up HugePages. What do I do? Well, we have a script available in my Oracle support that provides a shell script that automatically checks the SGAs in your server and provides you the amount of HugePages you have to set up. But this may be a new server you're building or configuring, and you may want to calculate that ahead. You don't have an SGA running. So the formula is very simple. You put together the total SGA sizes you're going to run in a given server. You divide it in megabytes. You divide it by 2 megabytes again, and add 42. Why 42? You would be asking. Well, 42 is the answer to the live universe and all. So I think it's kind of cool. All right. Implementation steps. Depending on what you're doing and what kind of software, hardware you're using, there may be a few extra things you do, especially to be done, especially on cloud systems or virtual machines running on whatever the virtualization hypervisor you have in place. For instance, let me take a look at my notes. But basically, there is in KVM hosts, you have to enable at the hypervisor level the huge TLV file system, so you can enable HugePages for your virtual machines, that kind of stuff. All right. Obviously, you have to disable AMM for your instance. That is going to be HugePages. Best practices said that the use large pages initialization parameter should be set to only. Why? Because if you set it to available, which is the other option besides none, if I'm not wrong, you may end up with a mix of an SGA being stored in HugePages and regular pages, which is, as you may know, it's going to create problems in terms of managing memory, etc. So either have your instance to be able to allocate the whole SGA into HugePages or to not start up at all. So you are sure that you do not encounter funny stuff going on with performance later on. Remember to disable transfer HugePages. Depending on your system, you may have to do it or not. It may be disabled by default. The memlock kernel limit has to be raised to match the amount of HugePages you have set up, obviously. Otherwise, the user running the process that is allocating the HugePages may not be able to allocate the memory as much as that it needs. Obviously, you have to tell the kernel how many HugePages you need in the system. So when it boots, it already builds all the memory structures and manager structures to handle it. There are operating systems like SUSE that requires another kernel parameter called HugeTLB shared memory group. Basically, this is some sort of ACL, if you will, setting, telling the kernel which operating system group or groups can actually use HugePages. Once all this is done, typically reboot the operating system to make sure that everything is fine. Start or restart your Oracle instance. And well, this is more a personal preference than anything, but I find that TuneD profiles are very useful in Red Hat kind of systems to handle all these HugePages related configurations. And beware, because in some operating systems, TuneD may be enabled by default in the background. You may not be aware of it, and it may be interfering with your manually VM kernel parameters, which happened to me, of course. And it's not nice. It takes a while to troubleshoot and find out. Hooray! We did it. We have set up a total of 1,056 HugePages. 287 HugePages are free. Only one is reserved. Our database has started up, and as you can see, we have a memlock soft limit of 2 megabytes per HugePage. We have 1.5 gigabytes of SGA, and we have enough available regular pages and HugePages. And finally, down there we can see that we have a page size of 2 megabytes. There are 1,000 available pages, which translates to 2 gigabytes of HugePages available. The database expects 770 HugePages to allocate 1.5 gigabytes of RAM. It's been able to allocate all the required ones, so no others. Ta-da, HugePages are in place. Other operating systems, Windows, large pages. Yes, they are there. If you happen to be running an Oracle system on Windows for whatever reason, it may not be straightforward, but they're available. You can enable them at a seed level. It's the seed level. It's a fine-grained access control, and it's really, really interesting to do that in Windows. It's only used for SGA, not for PGA, like I explained before. It's not considered in the working set of the memory system, which means that a process that is accessing an SGA in HugePages won't be reporting that memory it is using. So be careful with the memory usage metrics here. Again, the startup times may be slow because of all this memory management that the process does when it starts. So be aware of this when you use large pages in Windows. And the recommendation is to limit it to their warehousing type databases, where huge amounts of data has to be loaded up in memory to be processed. Okay, a few real life fun. I'm going to speed up a bit. I'm going to try and leave. I see a few questions. So let's try and get a few minutes at the end for Q&A. So the first case, one rack node division. We had two node cluster, not a big one, and one node simply got evicted. We saw a timeout in the logs, responding the typical rack situation when one process does not reply in time because of whatever the reason, and that is a critical process, and it gets evicted. But there were no other no evidence of what may have happened, any error messages anywhere, that kind of stuff. That was not there. So we used the SAR tool, Linux SAR tool, right? Which is our help. It's our friend in this kind of situations. So with SAR, we can see that close to 100% of the memory was in use, which for a 64 gigabyte node like this one, it's not typical. It's not common. You should not be seeing such kind of memory. Interesting enough is that we see lots of major memory faults, memory page faults prior to the node eviction, which is a symptom. Typically, a major fault is basically saying, a process is saying, okay, I need this from memory. The kernel says, hold on, this is not in memory. I have to go to this. So wait for me. And that's a lot of page faults. So the node came back afterwards, and after the eviction, and it joined the cluster again, and we took a look at the memory info. And as you can see, we have quite some page tables here. That's roughly 12 gigabytes, no huge pages at all. So what happened here was that there was memory pressure in the node, a critical rack process timed out from the reason, and it was evicted because of that typical situation. How did we fix it? Well, HugePages enabled these 12 gigabytes release a lot of memory pressure in a 64 gigabyte system, and it never happened again, at least not that we know. Swapping. See, this is something funny that happens. Remember I mentioned that HugePages are not swapped to to disk. So this system was a very small system with 2 gigabytes SGA. The database was not really very much used, only a few days a month for some reporting. There is this VM swappiness kernel parameter, which we didn't review at the moment, but by the time and the version, it was probably set at 60, which is pretty high, given that the recommendation is to set it to 1 or 0, which means, sir, don't swap memory to, this is a database. I don't want its memory pages to go to this at all. But in any case, we were getting lots of alarms that the system was reporting heavy swapping. It was just a little bit of memory being swapped out, but there was no memory pressure overall. What was the problem? The problem was that there was this mechanism in the kernel that basically said, this memory has not been used for a while. Let's swap it to disk just in case. And that is obviously the moment we enabled HugePages, which was not really necessary except to avoid these false alarms coming every now and then. Not a big deal. All right, this is a big one. We had a relatively big system here, with a lot of CPU available. And every now and then, throughout every month, we will be getting this very high load on CPU. The system was very unresponsive, but it didn't crash. So it was a big machine. It was at 1 terabyte of RAM, 250 gigs of SGA, 100 gigs for PGA. Not a big deal. I mean, we have a 1 terabyte, lots of available memory. We shouldn't see memory. It shouldn't be related to memory, right? We went down so many different rabbit holes trying to figure out what was going on. We noticed also that the peaks of CPU came with a lot of sessions, 3,000 sessions. When the system would typically have only 1,000, roughly, it will be peaking up to 3,000 sessions. That may give you an idea. The SQL, the workload, everything didn't change, but it was tricky. What we found was that with SAR, again, our friend, is that during the problem, we had this huge system percentage of CPU usage, which typically means that the kernel is doing something, and we don't know what it is. But this points to the problem sitting outside of the database, not inside the database. Well, we took a look at the memory structures, and ta-da, 440 gigabytes of page tables. What was the problem? The problem was that the page tables were so huge and there were so many that the kernel was spending lots of time handling them, putting them up and down, reading, unloading, that kind of stuff. And that was causing the delay. Obviously, the moment we enabled HugePages in the system, this thing went away. The customer took a month and a couple of these situations to occur again to apply our suggestion. But after all, we never heard about it again, so I think it's good. As you can see, during the problem, the free memory went down very, very fast, and that was part of the that was triggering the kernel to work with the page types. Okay, so summary, just to give people 5 minutes for questions. HugePages are usually good to have. I would say they should be almost mandatory nowadays. A very good practice. We've seen how to implement them. It's relatively easy if you there are not that many changes to be made. We've seen where to look for information about HugePages and page tables in Linux, just to make sure that everything is all right. When you're in trouble and you don't really see anything in the database, and you have to look at the OS level just to see if there is anything there that can give you a clue of what's going on, SAR or OS Watch Black Box, which is nowadays deployed with TFA in rack systems, is your friend. They have statistics of the system, what's been going on, etc. And the very most important advice I can give a junior DBA and a refresher for seniors: best practices will prevent issues. So go for them. A few references. There is this AMM blog post by Untitled, very interesting. It explains how AMM is used and implemented in Linux systems. I always learn a lot from Tanner. Fritz Holland has a very interesting blog post on why big SGA may get to a slow instance startup. We have this MOS, there's more Oracle support now to calculate the required HugePages, all that stuff. If anyone wants these references, I will be happy to share them on Twitter, email, or whatever. So time for Q&A. Mirella, how do we do this?
As you wish, I can read for you, or you can check the Q&A. You should have access to Q&A.
Okay, I'll do it myself.
Yes,
so
I think it's easier.
Is asking, does PGA use HugePages? I saw this and I said it live. As far as I know, no, PGA does not use HugePages, but it may change in the future. I don't know. And that applies for to Linux. So we have someone asking, can you throw some light on the additional 42 pages, please? Fruitlessly not. This is in the Oracle support note, the plus 42. I didn't find any information regarding why 42. I just find it fun because of this reference to the Hitchhiker Guide to the Galaxy, but I cannot explain why 42. I don't really remember what other values are available for use large pages, but I don't remember the values exactly, but basically you have three, which is use HugePages only, use HugePages as much as you can, and the rest of the SGA you allocate in normal size HugePages, which is a very, very bad idea. And the final option is none, which means don't allocate HugePages, which is something you don't really want to do. The script does not derive the number of HugePages you need because it actually reads the memory. The script accesses the kernel memory pages and calculates the amount of shared memory that is in place and gives you the number. So if there is no database instance running, you don't have a base, or you don't have data to calculate based on. So the script won't do that. Can we use different sizes of HugePages? Some systems allow for bigger HugePages, and there may be the possibility that I don't think so. It makes little sense. There may be a system out there that allows for having HugePages of 2 megabytes and 8 megabytes. Doesn't sound like a good practice or a good idea at all to have different kind of stuff. The maximum size of HugePages depends on the operating system. I've seen systems that allow up to 4 gigabytes. Linux right now, I think, allows for 8 megabytes or 16 megabytes, maybe. Don't trust me 100% on this. But it will be the documentation of your operating system that will give you the final answer. The best practices for transferring HugePages in Red Hat 6 and above, implement them. The moment you have more than 4 gigabytes of RAM available in your system, put them in. How much? Typically, you would be using, if you're not using this host for anything else than databases, a reasonable amount of memory to be used to be set up as HugePages is 80% of the total available RAM. Obviously, this will leave relatively little room for OS and PGA and UGA. So be careful with this. Depending on the kind of load you have in your system, if it is a very busy OLTP with lots of sessions but very small, it may be wise to reduce the amount of HugePages to only 60% of the system run. If you have a data warehouse running on, and you can afford to get up as much as 90% of the system run, go for it. It will help you. Okay, Dimitri is asking why 42. I answered this one already. I don't know. I'm sorry. Bartosz Zielinski is asking if I ever seen set bigger than 2 megabytes. No, I haven't. Consider that we're going from 4 kilobytes to 2 megabytes. That's a reduction of 500 times. That's a lot. 500 times is a lot. So 2 megabytes is typically enough. But if you're dealing with a system that has 3, 4, 16 terabytes, it may be interesting to try bigger sizes. Babus Basan is asking if Exit check or check evaluates huge pages. I think so. I'm not sure. I haven't run one of these for some time now, but I think so. And it's a warning if you don't have them enabled. Goran Santolic is asking, what about running multiple instances on server and formula for huge pages sizing? It's the same. The kernel only cares about the total amount of shared memory that you want to store in huge pages. So if you're going to run 3 instances with 1 gigabyte each of SGA, you will ask the system for at least 3 gigabytes of huge pages. And then each of the instances will allocate only the number of huge pages it is being asked to. Kind of word of caution here. If you have, you may have to want to increase the SGA size at the moment later in time. So if you can afford it, do not allocate just enough for the SGA you plan to have initially or what you have right now. Try to add 25% or 50% more if you can, all right? So I've been 3 minutes over, sorry. Thank you everybody for joining. See you around. Bye.